Hello my dear students, welcome back to NEET World. So today we will be starting a new chapter here. So this is a very useful session for all the students who are preparing for NEET, JEE and EAPCET exams, okay. And in this session I will be discussing thermodynamics, okay. So thermodynamics, okay. Here previously I have made few sessions on thermodynamics, okay. So in this session we will be discussing thermodynamics with a numerical approach, okay. Let's begin the session with very basic numericals, then we will slowly goes to the higher level, okay, right. So now I hope you know that there are basic terms to be used here, something like what do we mean by system, surrounding, boundary and all those things. I do not want to explain again all those things because you are already much aware of it. See, if you are doing a reaction, for example this is a tea cup we have, otherwise you just take a normal thing here. For example here I am saying this is a thing in which we are doing the reaction. Let us say we are talking about chemistry in a chemical reaction. So in this thing there is a chemical reaction taking place. Now this whatever the thing I have considered here, this container whatever I have taken, it is under my observation, right. So now the species that is under our observation is considered to be system. Now the remaining portion is considered to be surroundings, okay. Now system plus surroundings is considered to be universe, okay. These are very basic terms, okay. Now look at here, there is something called first law of thermodynamics. What this first law of thermodynamics explains us? Tell me what this first law of thermodynamics explains us. Yeah, it says about the total energy of the universe remains constant. What it will says, total energy of the universe remains constant. It means you cannot create energy newly or you cannot destroy the energy, okay, but that energy can transform from one form to another form. A mechanical energy can convert it into electrical energy or electrical to the mechanical, like that we can convert the energies, but we cannot destroy or we cannot create, okay. We just only transform from one form to another form, okay, that's it. This is what first law says about, okay. Now here if you see the first question here, a system does 100 joules of work on surroundings by absorbing 150 joules of heat. Calculate the change in internal energy. See, it's very simple. The change in internal energy is equals to the heat change, that is Q represents here heat. So change in heat plus work done, here dW, okay, work done. So now what is the values they have mentioned? System does 100 joules of work. It means, remember here I have mentioned dW now, so this is work done, okay. So now this work done, see, system does this much of work, it means work is done by the system, it means that system is doing some work. How much work it is doing? 100 joules of work right now. So now it means from that system 100 joules of energy, that is work is done right now. So that is work done by the system means does work now. So it should be taken as minus 100 joules. Here dW in the place of this I should take here it as minus 100 joules, okay. Why? Because that work is done by the system now, so it goes out of that see, if this is the system, if work is done on the system it should be plus, if it is work done by the system it should be negative, okay. Similarly if heat is supplied to the system it should be positive, if heat is released from the system it is losing from here now, so it should be represented with negative. These are the notations you must understood in order to solve these very basic questions first, okay. See, I am going to give you concept plus basic. You please stay tuned or stay connected with our session till the end, so that you will feel, definitely you are going to feel somewhat confident about this thermodynamics, okay, right. Let's discuss. Yeah, so here dq. So what about dq? Change in heat. Now see, a system does 100 joules of work on surroundings by absorbing. It means system absorbed the heat now, so it should be positive symbol now. So positive, how much it is absorbed? Plus 150, that's it. So now change in internal energy is how much? See, 150 minus 100. So this is 50 joules. it means plus 50 joules. So the internal energy of the system, example, initially it has some energy internally. Now by adding this much amount of heat, it is done some work, and now its internal energy also increased by 50. Now what is the change in internal energy? 50 joules. Okay, so we have option number 2 as our answer for this discussion. Hope the discussion is clear. Is there any confusion? Please let me know in the chat box. Okay, I will be looking into the chat box. Please let me know in the chat box if there is any confusion. Okay, right, let's move forward. Yeah, few more questions here. Now look at this question. Look at this question. Out of the following, the correct statement is, see, they have mentioned something like W is a state function. Yeah, so there are something called state functions and path functions. Okay, so path function means that particular term depends on how the final result is coming from the initial, means how this process is taking place. For example, it is at here, this is the initial point, this is the final point. So now path functions depends on path followed, how this final result is obtained from this initial. Okay, so it can be like, it depends on how you are following the path. Okay, so there are something called path functions, state functions. See, heat, now if you pass the heat from here to here, yeah, so this will be of different amount of heat is traveled, I mean utilized, or if you pass from this level, it will be of different amount of heat is utilized. So here Q is heat is a path function, it depends on the path followed by the system. Okay, similar to this, work is also path function. Work means what? For example, you are standing in a 5th floor of a building. What I am saying, you are in the 5th floor of a building. Now you are simply taking some amount of luggage or weight in your hands from 5th floor to ground floor using the stairs, like staircase. Okay, like from the steps. Okay, so now you need to utilize more amount of energy in that case when compared with taking that luggage by using a directly like something like a lift or something like this, because there you are not using any of your energy, you are just going and you are standing in that lift and it is taking you to the down floor right now. So it means very less amount of energy is used when you are going like this. But when you use the stairs and going like this means more amount of energy is utilized now. So if path changes, the work, whatever the work you did during that process also changes right now. So work and heat, these two are considered to be path functions. Now when it comes to a state function, so what are the state function examples? Like temperature, pressure, okay, and internal energy change, okay, and enthalpy change, all these are comes under state functions. Okay, right. So they don't depend on, these don't depend on path function, I mean path followed by that process, okay, during that system, during that process. Okay, it depends only on initial and final steps. Okay, so these are some examples for state functions, right. So now you can look at here, so work is a path function, they are state function, they are saying no, it is a path function, this is incorrect. Next, so Q is equals to E, delta E for isobaric process. What do we mean by isobaric process? See, pressure should be constant. See, pressure constant means what is the first law of thermodynamics I told you? du. Du is nothing but here dE, internal energy, is equals to dQ plus PdV. It means why we are writing this? Work done, dW, right now. So work done can also be written as minus PdV. See, P means external pressure, dV means change in volume, and here dQ. So du equals to dQ plus dW. So during isobaric process, pressure is constant. Yeah, there is no change. If pressure is constant, you just put that value over here. So this should be the final equation. But they are giving delta E is equals to Q only. No, this won't work. So this will be the case when it is isochoric process. It means if change in volume, if volume is constant, change in volume will be 0. So this second term becomes 0. This work done becomes 0. Now du equals to du only when it will be isochoric process at volume constant case. So second statement is incorrect. First statement is also incorrect. So Q is equals to 0 for every cyclic process. See, what do we mean by cyclic process? Now see, if any thermodynamic process, it means I am at here, let us say I am reaching like this. See, it is happening in a loop now, in a closed loop now. So if it is happening in a closed loop, we can say it is a cyclic process. Now converting from 1, 2, 3, 4, again 3, 4, again to the first. So this is happening in a cyclic loop now. Yeah. So for a process happening in cyclic loop, for a state function, if it is operated in the cyclic loop, then you can say change in that function value will be 0, because what I told you, for a state function the change in that value depends on initial and final values only, final steps only, right now. See, initial step is 1, final step also this one only now. So if it is happening in that cyclic loop, the change will be in that state function will be 0. If z is a state function, so integral of that z dz will be 0. So that change in that state function will be 0. So this is applicable only for state functions. For path function it may or may not be. So they are saying here for every cyclic process, not for every cyclic process, might be for few cyclic process, okay, because q is a state path function, not a state function. Yeah. So for delta E is equals to 0 for every cyclic process. Yes. What do we mean by delta E? It's a internal energy change. No. So for internal energy change, if it is happening in the cyclic process, change will be 0. So fourth option will be your perfect answer for this question. Okay. Right. Let's discuss few more things. Yeah, let me take you, yeah, so based on our discussion, it means previous discussion, can you answer me based on the first law of thermodynamics, this question, read this question clearly and mention your answer for this in the chart box. Very simple, very easy, okay. See, heat is provided, work done by the system is provided, you just tell me what is the internal energy change during the process, okay. Just look at this and answer me. Okay, right. Let me take you to the some good quality questions, a little more interesting. Let me take you there. Yeah. So let's do this from thermochemistry point of view for some time. Or otherwise, let's solve this question first. See what this question is saying. Once read this, the heat of combustion of ethanol. So what is the formula of ethanol? C2H5OH. Okay. So this ethanol upon combustion produces, what it will produce is carbon dioxide plus H2O, CO2 plus H2O. I hope you know that nowadays in petrol, if you see the new petrol that is like available in the petrol bunks, along with our fuel, that is petrol, we have 20% of ethanol also. So now ethanol is also blended with the petrol. So that's why if you see the new bikes, it is mentioned as E20 petrol, right? I hope you are aware of this, right? So now ethanol can also be act as a fuel but not efficient like petrol. Anyways, we will solve this question. So here 2 carbons are there, here also 2 carbons. Next, how many hydrogens are there? 5 plus 1, 6. So here also 6 means 3 hydrogens, fine. It is carbon hydrogens are balanced. Now what about oxygen here? See, 1 oxygen over here, reactants at this side. So here 2 to the 4 plus 3, 7 are there. So 1 here, so means 3 here, 3 to the 6 plus 1, 7. Both sides same number of atoms right now, like this. After balancing this, now assign their physical states. See, heat of combustion of ethanol determined in bomb calorimeter. This is the value they got, and this is happening at 25 degrees Celsius. So at 25 degrees Celsius, ethanol will be in liquid state, oxygen will be in gas, and carbon dioxide will be gas, water will be liquid. Okay, you need to assign their physical states. That's it, first of all. Now, what is the enthalpy change for this process? See, enthalpy change. So there is something called enthalpy, H. So H is equals to internal energy plus PV. Okay, pressure into volume. So change in enthalpy means delta H equals to delta E plus delta P delta V. Okay, this is the final formula we'll get. Okay, right. So now from here we know ideal gas PV equals to nRT is there now. This is what ideal gas equation. So now here in the place of PV I can also write this thing. So why I am writing that, I will explain you. See, this bomb calorimeter means it is a closed container. What I am saying? It's a closed container. Now whatever the heat that we have seen here, that is nothing but whatever the heat we have calculated here, that is heat content of this system calculated at constant volume. So the heat content of the system calculated at constant volume, okay, is considered to be internal energy, that is delta U or delta E. Okay, so now how much value they have mentioned this as? Minus 670.48 Kelvin. So this is the internal energy value we got. So this is the internal energy they have provided, but they are asking us to calculate enthalpy change. So in order to solve that, we need to know this PV value here. So for that, I do not have PV value, but I am placing there this nRT because temperature is mentioned. So using that we can calculate it. Okay, so now delta H is equals to delta E place, in the place of this PV I am writing delta NGRT. So what is this delta Ng? So delta Ng is nothing but number of gaseous products by number of gaseous reactants. How many gaseous products are there? See, this is a liquid, this is a gas now. So delta Ng can be now 2 minus, this is also gas, 2 minus 3, this is minus 1. Okay, so delta H is equals to delta E minus 1 RT, that's it. This is your final equation to be known. Okay, right. So further, can you solve this further? Can you try this further? If not, I will explain, no issues. Right. So see, they are also saying your answer should be in calories. Okay, so it is easy. What we can do is delta H is equals to delta E. How much it is? Minus 670.48 kilocalorie minus R. R is how much? So R value in calories you can take approximately 2 into 10 power 3 kilocalorie. 10 power 3, okay, 10 power minus 3 kilocalorie you can take. Okay. Yeah, they are asking answer in kilocalories only. Right. 10 power minus 3 kilocalorie you can take. Kilocalorie you can take. So R I am taking here. If they are asking for joules, you can use 8.314 10 power minus 3 kilojoule per Kelvin you can take. This kilojoule per Kelvin per mole, this is the units for R. Okay, since they are asking for calorie, I am using this data. So R is how much? 2 into 10 power minus 3 kilocalorie. And what about temperature mentioned? 25 degrees. Now convert into kelvins, it is 298 Kelvin, right? Yeah, that's it. We got almost, we got here, right? So minus 670.48 minus, see this one 10 power minus 3 is there, so I am writing this as 0.298, that is nothing but almost 0.3. So 2 3s are 6, so minus 0.6 kilocalorie. Okay, that's it, kilocalories. Okay, so this can be now 8, 4 plus 6, 10, it means a 0 here, 1 here, 1, 7, 6. So minus 671.08 kilocalorie will be your answer for this question, right? So where do we have that option? Option number 2 is perfect answer for this discussion. Hope this is clear. Guys, if this is clear, please mention clear in the chat box. Yeah, let's move forward. The next question here related to this only. Let's calculate. With the same relation, we have one more question here. Let's do this once. Guys, you just try from your side. Yeah, there is no issues. Yeah, just give me your answers, anyone. Guys, I am expecting answers from anyone in the chat box, live students who are watching it. Yeah, let me do it. Yeah, so what the question says here is, consider the reaction at 300 Kelvin. Okay, this is the reaction they have mentioned. Now delta H enthalpy change they have mentioned, and they are asking for internal energy change. Okay, and this is for 3 mole of H2. See, they have given it for 1 mole, like 1 mole of H2, 1 mole of Cl2 forming 2 moles of HCl. That is fine. Okay, now what is the relation I have given you for delta H and delta U? Delta H equals to delta U plus delta Ng RT we can use here. Okay, because pressure volume values are not mentioned, so you can use this. Okay, because temperature is mentioned. So first of all you need to know what is delta Ng here. So number of gaseous products are how many? 2. Gaseous reactants are how many? 1 and 1, that is also 2. So this second term becoming 0 now. So you can say delta H is equals to delta U. It is simple. So this is done. Now how much value they have mentioned? This is equals to minus 185 kilojoule per mole. This is for 1 mole, this is per mole. Okay. Now they are asking it for 3 moles of H2 for completely reacting with 3 moles of Cl2 to form HCl. So how many moles of HCl form? 6 moles. Okay, because for 1 mole it is forming 2, for 3 moles it will form 6. That's it, double. Okay. So now 1 mole this much now, for 3 moles means what you need to do? Multiply with 3. So minus as it is, minus 185 as it is, multiplied with 3 gives you the exact amount. 5 3 is a 15, 1 next here 24, 5, 2 here, and here 3 plus 2, 5. So minus 555 kilojoule, like 555 kilojoule per mole. This is your final answer, right? So now look at the options. Do we have this? Yeah, option 3 is 555 only, but it is positive. We got it as negative. So what is a suitable answer for this? None of these. Okay. So this is your answer, because we have a minus symbol here, but there is no minus here. So this is not the exact one. This is the exact one. Okay. Hope it is clear. Right. Let's move forward again. Yeah. Now I will be explaining you one question from entropy related question. This is entropy related question. So what do we mean by entropy first? See, entropy means change in heat dq with temperature, change in heat by temperature. Okay, right. So now here they are saying 5 mole of an ideal gas expand reversibly from a volume of 8 to 80 decimeter cube at a temperature of 27. The change in internal change in entropy is, see, first of all, to the same question we need to know how to calculate work done also. Okay, this I will tell you very easy way, you will get direct answers. But before that, I also wanted to explain work done for the same question, then you can use this. See, they are saying at this particular temperature now, so this condition is considered to be isothermal, because a specific temperature is mentioned now, temperature is fixed, so it is isothermal process. What is this? Isothermal process. Okay, where temperature remains constant. If temperature remains constant, that is how much? 27 degrees means 300 Kelvin. So this is fixed value. Okay. So now you can use first law of thermodynamics, that is du equals to dq plus dw, right? So we know internal energy is directly proportional to temperature, but here temperature is constant now, so there is no change in internal energy. If temperature is constant of something will be 0. So here du also 0 for first from this isothermal process. Okay, so du will be 0. If this is becoming 0, now dq is equals to minus dW, means they have opposite sign, that's it. Okay, right. So now dW means what? It's a work done. So you can use this formula, dW is equals to, I am writing dW equals to minus P external dV. So for a reversible isothermal process, internal pressure, external pressure almost the same. So I can use here P internal, that is ideal gas pressure here. So ideal gas PV equals to nRT is there now. From that N by V RT also we can write. Okay. So here I am writing N by V RT in the place of P. Okay. N by V RT. Okay. So here N by V RT into dV we have dV. So this is what we have. So I am writing this constant RNT aside, nRT aside, next 1 by V dV we have, and here we have dW. So now just integrate this thing, 1 by V dV. So something like 1 by x dx type of formula na. So that is ln x. So minus nRT ln V2 by V1 if I apply lower limit and apply limit. So here change in work done, that is W only here. So this is a final formula you need to remember for work done for isothermal process. Okay. So now if you see work done, if you see this work done as well as dq, both of them are equal, right? So you can use here isothermal process entropy will be equals to the same formula you can take here, nRT ln V2 by V1 by T. Why T here? Already T is there now, so this T is removed. So isothermal process entropy will be nR ln V2 by V1. Okay, V1. You can use this formula to calculate entropy change. This is for work done. Okay. Now if they ask for work done, what you need to do? So how many moles they have mentioned, you need to take that. In how many moles they have mentioned, it has 5 moles. Okay, just I will tell you here 5 into, they are asking in joules now, you can take 8.3 into ln I am writing 2.303. Okay, and the next R value I have mentioned, temperature is how much they mentioned, 27 means 300 Kelvin. Okay, and log V2 is final volume is 80, initial volume is 8, 80 by 8 is 10, log 10 is 1. Okay, that's it. So upon simplifying, we are going to get work done for this question. Now in the question anyways they are not asking about work done, this is an extra information I just want to provide for you. Okay. So here as per the question they are asking only about entropy change in isothermal process now. So entropy change is equals to N, how many moles? 5 moles, and R is 8.3. Okay, and the next one here is ln is there, I am using 2.303 log V2 by V1, 80 by 8. So this is 10, 10 means log 10 is 1. So 5 into 8.3 into 2.303 will be your entropy change during this isothermal process. Now look at this 15. Okay, so this value is around 19.1. How much? 8.3 into 2.303 gives you around 19.1 and into 5. So this will be 9. Okay, 95.73. Okay, so this is expansion now. So there is no negative sign anywhere here. So always remember entropy, expansion means positive. Okay, that's it. So greater than 0, that is my plus 95.73 73 joule per Kelvin is your answer for the discussion. Hope this is clear. Clear or not? Third option we got as an answer. Right. Let's move forward. Let's move forward with one more question. We'll come back to this for again. Yeah, we'll come back to this. Just give me a time. Like let me explain this entropy question one more. See, what is the formula for entropy? I told you. So entropy change is equals to change in heat with by temperature. Right now. So now read this. 2 mole of an ideal gas is expanded irreversibly, isothermally. Okay, it means fixed temperature until its volume is doubled. Okay, and 3.3 kilojoules of heat is absorbed. Okay, observed from the surrounding. Determine the delta S surrounding. See, surrounding is heat is observed from the surrounding now, and they are asking for surrounding only, entropy change for surrounding. So now what I need to take is, this is for system when they are asking for surroundings. See, because heat is absorbed from the surrounding now, so this is minus here. Surroundings temperature loses right now. That's why I am using minus dq, because what we are calculating it for surrounding, not for system. If you are taking for system, it should be plus, but they are asking heat is absorbed from the surrounding. If it is heat is absorbed from the surrounding means, what about surroundings heat that is given to other system now? So it is giving heat given from the surrounding to system. It means surrounding should be negative, system should be positive here. Okay, that's why this negative symbol here. Okay, next minus, how much heat it is given? Minus 3.3 kilojoules. Okay, kilojoules I am writing as 1000, kilo as 1000. Okay, joules, because all answers are in joules only here. And temperature is 27 degrees means 300 Kelvin I am writing. Yeah, so these two zeros, so it is becoming 33 by 3. So 33 by 3 means 11. So it is minus 11 joule per Kelvin. Okay, this is the entropy change for surrounding. Okay, is this clear guys? Everyone, is this clear? Okay, right. So if you see the options, we have first option as our answer for the discussion. Okay, right. Let's move forward. Let's move forward with few more questions. Look at this question now. The question says about ethylene plus HCl gives rise to ethyl chloride. Now during this process, enthalpy change value is this much, and they are asking for internal energy change. How can you solve this question? Once try. See, they have mentioned specific amount of ethylene as well as HCl in grams. Okay, so yeah, you need to use stoichiometric calculations here first, then you need to decide your final answer. Yes, tell me, how can we solve this? Use here, see what they are asking C2H5, C2H4 plus HCl giving rise to C2H5Cl. Okay, so now if you observe C2H4, how much quantity they have given? 70 grams is given. So as per the stoichiometric coefficients of this balanced equation, 1 mole forming 1 mole of this product. Okay, 1 mole of C2H4 means carbon is 24, 2 carbons are there, and 4 hydrogens 4. So it is 28. Right now, what is the amount they have given? 70 grams. Find the number of moles. That 70 grams, nothing but 70 by 28 gives you how many moles of ethylene here. So this will be how many times? 28 means this is 2.5 times. Means 2.5 moles of ethylene is mentioned, and HCl is how much? 73 grams of HCl. So 73 by HCl, this is 36.5. Okay, because for 30 Cl it is 35.5, for H it is 1. So it is 36.5. It is 2 times. So this is 2.5, this is 2. Okay, now if you observe, 1 mole giving you 1 mole. All of them are 1:1:1 ratio. So if it is 2 moles, it is less than the requirement. Now see, this is 2.5, this is excess, this is limiting. Okay, your calculation should be, it means amount of product should be, comes only from limiting reagent. That will be the deciding factor. So 1 mole of this HCl giving 1 mole of product. So 2 moles will give you only 2 moles of this product. Okay, So it means out of this 2.5 moles of ethylene glycol, only 2 moles is reacting, 0.5 mole is remained excess unreacted. Okay, I hope you got identifying limiting and excess reagent also with this discussion. Okay, so now this reaction is for how many moles? 2 moles now. Yeah, it's simple now. Use calculation for 1 mole, multiply your answer with 2 because it is for 2 moles because as per the equation. So delta H is equals to delta U plus delta Ng RT. Okay, as per the equation, all of these are gaseous only. Okay, so number of gaseous products are 1, gaseous reactants are 2. Okay, it is minus 1. So delta U they are asking, so I can write delta U is equals to delta H minus delta Ng RT. Okay, right. So delta H is given as minus 72.3 kilojoule per mole, minus, and delta Ng is also minus 1, minus of minus it becomes plus RT. RT is how much? Plus 1. RT is how much? R means here in terms of joules they are asking. Okay, and temperature is how much? It is 300 Kelvin. So R is 8.314 into temperature is 300 Kelvin. Okay, here it is in kilojoules. You should take here 8.314 into 10 power minus 3 kilojoules. Okay, this becomes how much? 0.3. So 8.3 into 0.3 we got. So 8.3 into 0.3 is 3 3 is a 9, 9 3 is a 8 3 is a 24. Okay, around 2.49 will be your answer here. Okay, this will be 72.3. So this is in terms of kilojoule per mole. Okay. Finally, what you consider here is just consider 72.3 and 2.5. So it will be how much? 13.5 means it is 8. Here it is 11 means 9 and 69. So it is minus 69.8 kilojoule per mole. Okay, so this is the enthalpy, internal energy we got. This is per mole. So how many moles it is involving in the reaction? 2 moles now. So multiply this 2, that's it. 69.8 into 2. So 6, 1, 18, 19, 1, 12, 13. So 13. So 139.6 kilojoule per mole. This is your final answer. Okay. So if you see the final answer here, option D as perfectly minus 139.6 kilojoule per mole. Okay. I hope this question is also clear. Guys, if there is any confusion, please let me know. Yeah, let's discuss few more questions. Yeah, this is the question from entropy related again. The entropy change when 2 moles of ideal monoatomic gas is heated from 200 to 300 degrees Celsius reversibly and isochorically. So it means here you need to know that formula delta U. Wait, before going to that you need to know this. See, actually formula will be this one, NCV ln V2 T2 by T1. But you might be thinking how this formula we got. Okay, how this formula we got here. So because entropy change is equals to dq by T, right? dq by T. Now as per the first law, what we have, du equals to dq plus dw, right? So from these, what I am writing, dq is equals to du minus dw. Okay, so in the place of dq I can substitute this now. Okay, so du is nothing but NCV dt. What is this? This is NCV dt. And what about this? Here it is minus of minus PdV, that is plus PdV we will get. So this is about dq. Okay, so now what is constant here? Constant. Isochorically means volume is constant now. So this is dqv. If V is constant, change in V will be 0, right? So now what we are remaining with, dqv is equals to NCV dt. Yeah, we got this. So wherever you have dq, there we can substitute NCV dt. So here I can write NCV dt by t. That's why I am using that equation there. Okay. So NCV dt. So upon integration of this equation, what happens, tell me? NCV dt, 1 by t dv means 1 by t, dt means ln t, that like 1 by x dx, integral of 1 by x dx is ln x, right? Now that is why we got this equation upon applying upper limit and lower limits like this. Okay, that's it. I hope up to here the discussion is clear. Okay, because directly if I give this formula, you might be having a doubt how we got this final equation conclusion, right? So these are the steps to be followed. Okay, then next one more thing here, there is nowhere here CV in the given options, but they mentioned it as a monoatomic gas. Now if you have studied equipartition theorem in your physics, you might be aware what do we mean by CV here. So CV comes from we have a equation like this, internal energy du is equals to CV dt we have. Okay, so now internal energy for a monoatomic gas, internal energy change for a monoatomic gas depends on translational degrees of freedom. So for a monoatomic gas it is 3 by 2 RT. Okay, for each translational degree of freedom half RT. So there are 3 translational degrees of freedom along x, y, z axis. So it is 3 by 2 RT. So upon derivating of this, we will get CV is equals to 3 by 2 R. So this is for monoatomic gas. For which one? This is the value for monoatomic gas. Okay, right. So delta SV is equals to how many moles they are saying? For 2 moles now. So 2 n equals to 2. CV means 3 by 2 R ln T2 by T1. So T2 is how much? 300. So 300, there is no degree Celsius, you should be using only Kelvins here. 273 plus this 300. So it is 573 the VT2 plus, and here 200 plus 273, that is 473 in the denominator, that's it. So this is the final equation we are going to get, 3R ln T2 by T1. So where do we have 3R ln? Yes. So option 3 is your answer for this discussion. So what is your answer? Third option is your perfect answer for this question. Okay, guys, whatever I have discussed till now, all of them are very useful. I hope you followed all the discussions till now, whatever we did. Yeah, remaining questions and remaining concepts related to thermodynamics, we are going to do them in the upcoming sessions. I hope you will follow this session, this channel regularly, and you can make your preparation more productive and more effective. If you are new to this channel, click on the subscribe button, and if you like the content, please share this with your friends who are preparing for NEET, JEE and EAPCET, especially Telugu state students, those who are from AP and Telangana. Yeah, you can mention your concerns in the chat box, or you can directly reach us to our institute. This is in our Hyderabad itself, like you know, Narayanguda. So it is at Narayanguda metro station itself. Okay, just 100 meters far from the metro station. Okay, you can come, can interact with us, and you can join our courses also. Thanks for watching. Stay connected.